Welcome back. So today we're on Unit 6, Chapter 1, Lesson 4, or U6C1L4. And today we're going to focus on temperature around the world. In the last lesson, we focused on what is air temperature, or how does air get temperature or energy? How does it acquire energy? Now we're going to talk about the temperature around the world and what it looks like on a global scale. So to start today's lesson, make sure that you have access to Amplify as we do this, because you're going to go back and forth a little more often than usual for this lesson. So today's warm-up is asking you to move the green thermometer to one location that you think is cold, yellow for warm, and red for hot. I'm going to actually exit out of this and go into the Amplify website, which this is where you should have ended up when you clicked on the link. And we're going to go to the 1.4 warm-up. Again, we are trying to indicate where we think hot, cold, and warm are going to be. And notice that high energy I've placed next to red. High energy would mean more thermal energy, which would mean a higher temperature. So we're trying to correlate high temperature and high energy together. Thermal energy and temperature are not the same exact thing, but on the scale that we're talking about, if the air above an entire continent or country is warm, it's probably very high energy. You were to add a couple more of different things that you wanted to add, and when you're done, just click hand in. Now, I would like you to click next activity, and you should lead yourself onto this screen right here. I'm going to go back to the slideshow just because I have made it much prettier on here. So far, we know that energy from the sun is transferred to Earth's surface. Some of that energy then is transferred to the air above the surface. This tells us how energy from the sun can warm the air, but does not explain why different locations have different temperatures. So what we're looking at is, why do some areas get more thermal energy or more temperature or more heat transferred to the area of the air above it? So why do different locations have different air temperatures? So think about where you live, where your family is from, places that you've seen on TV. Why don't they all have the same temperature if we're getting the energy from the same source? So here is a map of global air temperatures, and pretty much they are universal in the fact that areas near the equator are much warmer than areas near the poles. The equator is the center part of the Earth, going across from left to right. And if we look at the tops of the Earth, where the poles are, and the bottom, we see that it is a much colder temperature. And just for those of you that like art, if you notice that blues and greens are considered cool colors, and purples are considered cool colors, and reds, orange, and yellows are considered warm colors, and they kind of correlate with this on this map. But a main part to acknowledge is that the center of the Earth is the warmest, and everything else precededly gets colder. On this map here, we have the pictures of Earth and how much sun those areas get. And if you notice, the equator is where most of the energy from the sun, they get the most energy from the sun. They get the most sunlight. the places that got the most sunlight also correlated with the hotter temperatures. This is a very easy connection here, but it's a big idea that we're going to need for the rest of this unit. So when we think about it, the closer you are to the equator, the more sunlight you're going to get. The more sunlight you're going to get, the more heat you're going to have. So one of the vocabulary words that you need to know is latitude. Latitude are the lines that go from left to right or right to left, and they indicate degrees from the equator. So if you look at 20 degrees north and 20 degrees south, they are both 20 degrees from the equator. This is very similar to the math concept of positive and negative numbers that you would have learned about while you were in a math class this year. And essentially, we're looking at the absolute value. How many degrees from the equator are they? They might be up, they might be down, or north-south, but they are still the same distance away from the center. Now, I'm going to go to the Amplify website. So now you've seen both of these website pictures. I would like you to click Next. And again, Next. And answer this question right here. It says, why do different locations have different air temperatures? This is our investigative question. Why do they have? So I want you to use the evidence from this map, these two maps, to come up with an answer. I want you to try to use the words energy, temperature, and latitude in your response for this. I am grading this as an assignment, so make sure that you get this one done. When you are done, I'm going to write answers so that I can continue. You want to press save and continue. Press pause at this time if you need time to answer the question. So this was the original map that you made when you did the warm-up. If you need to edit this, you are going to click right here on the 1.4 warm-up. It will bring you right to the sorting tool again, and you can change this. So I'm going to actually add more. So here, along this entire line, it doesn't matter where I place it, is also going to be a medium. I'm going to put high energy right here on the same line. If you notice, it's high energy in the middle, mediums as we go down one line, which is 30 degrees, and very low on the 60 degrees north, 60 degrees south. And again, I'm going to hand in because that will just update it. And I'm going to go back here, and you'll see that your picture has been updated. Once you finish that, click update and move on to here, the modeling tool. So I'm going to go back to the slides, and we're going to talk about what we need to do for our modeling, how the latitude of a location affects the air temperature. So back here at the Amplify website, I have this part right here. I'm going to open up the modeling tool. Again, where I got it from was Ocean, Atmosphere, and Climate. And it asks you for the goal, model how latitude of location A affects the temperature. So I'm going to go to location A. And then it says, note the latitude of location A. Select the star to open the side view. Now I have the side view. Tap the blue pencil to add information to your model. And here we have the blue pencil to indicate the model. I'm going to give you a few minutes to locate the model. I'm going to energy transfer. It's coming from the sun. And the energy transfer is leaving the land and leaving the water. Temperature. I'm going to say that this is very high. So I connected this, you can make this one red or orange, but essentially what we should get is that it comes down from the sun, it heats this up, and the rest of the air temperature is transferred back up. So if it heats the ground, remember that energy will move from high to low. If the air was cold, it's going to go and heat the air for as long as it needs to transfer the heat so that these two are the same temperature. So as it heats the ground, the heat from the ground is going to try to move into the space above it, which is the air. So it heats the ground and then heats the air right above it. I'm going to X out of this. Now, the reason why I made this so hot is because if you look at location A, it is on the equator. And because we know that the equator is the hottest part on Earth, I'm going to go back to the Amplify website, click Next Activity. And now here's what you're going to do. You're going to use the arrows again to create your idea and click on here. What they want you to do is compare two locations. Now we have one on the equator and one on the South Pole. The one on the equator we already did in the last unit. So we know that the energy is leaving the land and heating up the air, and the sun is heating up the land. I'm going to put this as hot. And likeliness that this is going to be pretty warm. Now, you're welcome to pause and do the second one on your own, but if you don't want to, you can copy along with me. Now, this is the South Pole. Remember, the sun is still transferring energy from the sun to the ground. But I'm only doing this to be fancy, but you can make them the both and connect them towards the middle. It won't make too much of a difference. I'll delete one just for simplicity. Now, the energy is still going from the land to the air. This is still the same as the one at the equator. But what's different is that this is only at a low amount of energy. It's not getting a lot of energy. If this is not getting a lot of energy, the energy that's being transferred up is going to be even lower. It just simply is that there's less sun coming to the ground of the surface in these locations. So if we look at both of these, this, again, the same direction, sun is coming down and the energy is transferring into the air. It's the same directions, but just the amount of energy in the South Pole is much different. When you're done, please make sure you click Hand In and go back. You'll see now that your image has automatically appeared here. And I'm going to ask you guys to do this assignment with me. It will count as a homework assignment. If you open up Oceans, Atmosphere, and Climate, it says go to Current Map Mode and select Air for Temperature View. So I'm going to do that. I'm going to click Air for Temperature View. Current Map Mode. Perfect. I'm going to click Air because that's what we're working on. Place location sensors at 1 and 2. Location sensors at 1, which is all the way up here in the northern part, and location sensor 2, which is in a medium zone. So now we have these two areas right here. Then it asks you to reset the activity. Record the levels of energy transferred from the sun and the air temperatures at both locations, 1 and 2. So look at the level of energy from the sun in area 1. In area 1, I'm going to look. Energy from the sun is low. If we look at energy from the sun, it is low. So I'm going to write low. And the air temperature is negative 3.1. Negative 3.1. In area 2, the energy from the sun is, let's look down here, it's right at that yellow marker, which is medium or middle. And the temperature of the air is 17.2. Now it asks you to reset and record area 3. So I'm going to reset and go to area 3, which again is on the equator. And we'll see that the area the heat transfer from the sun is very high. And I think it only gives you the option of writing the word high. And the temperature of the air is 30.4. And so the question is, how does the temperature of a location determined by the temperature of a location determined by energy from the sun and the location's distance from the equator? So to answer this question is, you're pretty much asking, how is the equator related to the amount of temperature, the level of temperature in a location? So how is temperature of a location determined by the energy from the sun? The closer an area is to the equator, the more sun energy, the closer the area is closer to the equator, the more sun energy will be transferred. This is because it has more sunlight. More solar energy will be transferred. This is because it has more sunlight. More sun is more energy, more energy is higher temperature. Hand it. Now, before you guys go, I want to look at one area of this map here, and I want to go back to session 2. And I want to focus on 3 locations. 1, 2, 3. For some reason, these areas do not follow the rule. This is all yellow besides this areas. This is all red besides this area. I'm going to go to our the slideshow just because I have some information there about this. And I want to focus on the idea that these areas that I highlighted as not following the rules are mountain areas. These concepts are going to play a key role later on in understanding movement around our planet, movement of air around our planet. But if you notice, all of these areas are mountain ranges, and they are lower in temperature than the surrounding parts. So I want you to keep that in mind, and during our meeting, we're going to do a little experiment to show you some reasons why this might be so. So the big takeaway for this is that the closer you are to the equator, the hotter it is. And the reason that it's hotter is because you are getting more direct sunlight. More sunlight, more thermal energy is being transferred. More thermal energy is being given from the ground back to the air, which gives us the temperature. All right, guys. Since your homework and classwork are on this, I'm going to be grading this. You'll see these grades posted on Jupiter within the next week or so. Thank you.